Yes, I'm the second guy from DLR in this session. So this already completely hijacked by DLR, this session, actually, a digital twin. But my work is on railway digital twins, because I have the honor to lead a group of railway engineers at the DLR. So the subject of the talk is aspects and ideas for the FMI-based modeling of railway digital twins. So I have to say that this presentation and the following presentation more or less go together because they are related to the same project. And I will focus more on the project background, on the approaches applied there, and on the challenges there. And I give a little example, while Gerhard afterwards will present a more elaborate problem of the project. Just the project background. So I'm working in Europe's Rail. It's a public-private partnership of the European Union and these companies you see here. And this joint undertaking is focused on 8 flagship projects that are in parts linked together. For instance, flagship project 2 is focused on automotive train operation. There's one flagship project 3 on asset management. There's one flagship project on new sustainable rail systems. And these flagship projects provide use cases for the flagship project where I'm working on. I'm leading a digital twin work package, and there's a work package in parallel led by Knorr-Bremse, who works on federated data spaces for railways. You will see later on that these both times are interrelated somehow. Okay, what is the requirements and demands? What is the job that I have to do there? Okay, these, for instance, flagship project 3, I scanned once the grant agreement. When you look for the term digital twin, it will appear 60 times in that document. So a lot of digital twin work, but the idea here is actually that that someone looks and try to organize this digital twin in a way that modularity, interoperability, and composability is possible with these different digital twins. That's my task. And my task is to support these digital twin works in these specific flagship projects. And it was a requirement of the core as well. I have to do that with functional backup interface. I have to apply that functional backup interface. And actually, the first 3 years of the project was my job more or less to get the core community familiar with functional backup units, so more or less. And I have to, next year, I have to submit at least 2 digital twins with real data in technology level 5. And later on, we'll proceed with the readiness level. Okay, what is the approach that we applied? More or less, this is a pretty old picture, already 20 years old from the automotive field. What we defined so far, we defined minimal component models, such as the brake model. Just important are actually the interfaces, how it's working together with the incomplete architecture. So the minimal model would be that you assume a driver command as input and torque supplied to the wheels and output, and actually what's inside the model doesn't make a big difference. Actually, that's not that interesting. The important thing is that the architecture is defined in such a way that in the railway case, for instance, the one brake supplier may be Knorr-Bremse, as defined the brake system. And if the OEM likes to replace the brake system supplier by Fevele, for instance, it's possible that these both parts are exchanged together. So here you see a comparable architecture provided by the OEM CAF, a Spanish company who makes rail systems. Well, that's the approach. What's the challenges? You may know where each time you use the term digital twin, you will get different understanding. Everyone understands something different behind that. And in order to present that, I use that diagram. For instance, each digital twin may cover a different parts of the system, maybe only digital twin of a damper, for instance, or of a complete rail system. You may digital twin may differ as respect to the different life cycle, or which period in the life cycle of time. So everyone understands something different behind that term. That's one problem. The other thing is simulation of rail vehicles is much more complex than automotive vehicles. For instance, if you have 32 wheel sets in one ICE train set, not only 4 wheels as a automotive vehicle, it's more computational demanding. And since we have to use co-simulation when we use functional mockup units, these co-simulations are less robust than simulations in one simulation tool. And then there's one thing that the high system level architecture, picture from another European project, what we call railway vehicle simulation is just covered by its 2 red boxes. So there are a lot of other functions in the high-level system architecture, like time scheduling, like command system, traffic management system. A lot of systems, so not only one architecture, one modeling architecture is capable of representing these functionalities together. So you have to organize several architectures that in parts overlapping somehow. So those are the challenges. This is the basic operation scheme, how we work right now. This is more or less a repository where the minimum models are collected. Then you have a repository with these architectures. And as regards the runtime environment, we refer to off-the-shelf products. As you know, you can simulate a functional mockup unit in MATLAB, or you can use a cloud service, or if you would like to use it on the vehicle itself, you may use it the FMI standard, for instance. Okay, that's already okay. I mentioned that the architectures, but at the end of the day, would like to interrelate that to a business case. The idea is there are a lot of data around in the area, but all owner of the area doesn't use it, doesn't give it away to the other companies who could use it, because there's no business case around it. So the idea is here that you use the Gaia-X approach, namely a federated data space. So at the end of the day, we would like to be able to provide such a digital twin components, introduce it as the component of the data space, and you can sell these digital twins you develop. That's let's say our vision that we would like to provide at the end of a row of projects. Okay, this is an overview of the use cases that are considered in that work package. The braking and traction use case will be presented by Gerhard later on. The last row presents the work flagship projects where this use cases actually come from. So, for instance, there are use cases, point machine, fault diagnosis, They cover the asset management of switches. There are asset management of civil structure elements, for instance, the HVAC system. So a lot of different use cases to be organized. Okay, now we come to the little example. It's about so-called Eurobalise. These are these yellow boxes there you see on the railway line. And these boxes are part of the control system of the railway system. So as soon as a train passes these boxes transmit telegram to the train. The minimal information that is transmitted that way is the ID of the Eurobalise and the location, but additional information can be exchanged that way. For instance, you can initiate braking applications. You can tell the train what's the maximum speed it has to run along the track ahead and stuff like that. So that's the Eurobalise, and the use case itself is organized like that. You have a real train that runs along a given track, and as soon as such an Eurobalise is passed, then the message is logged or provided as a data stream. A virtual train runs along the track, but now the track is specified by the design information, so as it use should be. And now we take algorithms that compares these both data streams and issues an alert as soon as a mismatch of these both protocols, these both data streams is measured, is realized, is noticed. Okay, I have to say, to the current state of the project, that what I called a real train here is still done in simulation only. Well, this will be done in reality in the course of the next year. Okay, what are the modeling issues? First of all, we have to model a vehicle running along a train. There I have the advantage that I'm the main author of the Modelica rail dynamics library, so I'm able to simulate a railway vehicle running along a track. I use that and export an FMU of that simulation. As a track input data, you may know, or you could imagine that every infrastructure owner has their own data format to describe his infrastructure. But here in the European project, there's one work package that provides ontology-based methods to convert infrastructure data from one country format, context-specific format, in other. So now we are able to use one XML format that describes the infrastructure. For instance, we need the track line as described as a 2x differentiable curve, so that the geometry of the curve is smooth. And well, the information on the Belize and their position is also covered by that infrastructure definition. Okay, that's on the modeling. Now, the simple example, actually, we have that one FMU that simulates the real train. We have the information on the local position is transmitted to the virtual simulation, and then the comparison of both is done. Here, the little plots above, you see we run with a constant velocity. You see the real Belize, as soon as one Belize is passed by. The idea of these ranges, and you see here that one problem, obviously, that this one Belize has not been noticed while overrunning. So that message could be provided to the infrastructure manager in order to initiate an appropriate action. Okay, so I'm coming to the outlook. Actually, what is ongoing right now? First of all, my task actually is to organize modularity, interoperability, and composability. So we have to consider that system architecture and try to organize architecture that overlaps somehow. That is not easy thing to do. We have to raise the technology readiness level. We haven't organized real-time data exchange so far. We have to organize the integration into that rail data space that has been installed or initiated at the last Intertrans conference 2024. We have to consider AI modeling. That's also a task we have to do. And this is actually the disclaimer I have to show as a task of the European project. Thank you very much for your attention.